so I'm going to go over multiplying and dividing rational expressions. And so even though we are multiplying and dividing rational expressions, you actually never really multiply or divide the rational expressions, maybe at the end to simplify some things. But typically, even though we're multiplying and dividing, you're not actually multiplying or dividing. So just keep that in the back of your head. If things look like they're going to get complicated, it's because you're trying to multiply and divide. But what we really want to do is we want to factor every polynomial we see in our numerators and denominators and hope to cancel factors, right? So when I say cancel factors, what I mean is you're dividing it to 1. And things will most likely cancel, so look for common factors, okay? So again, even though it says multiply these rational expressions or divide these rational expressions, it doesn't necessarily mean that is what you're doing. Chances are you're going to factor and then cancel things out. But a quick review of multiplying and dividing fractions. So when multiplying fractions, we multiply numerators together and multiply denominators together. So a over b times c over d is equal to ac over bd. And in this case, BD cannot equal, B or D cannot equal 0. Right? So again, going to those excluded values, that would cause a 0 in our denominator. And we know we cannot divide by 0. So again, if you could simplify, if there's any factors of A and B, simplify it. If there's any factors of C and D, I would simplify it before multiplying it out. Okay, but again, multiplying across the numerator, multiply across the denominator. When dividing fractions, we multiply by the reciprocal of the divisor, so that's the thing on the bottom or that follows the division symbol, and then we multiply our fractions. So if we have A over B divided by C over D, that's going to equal A over B times D over C. So again, excuse me, this is that multiplying by the reciprocal. And so we get AD over BC. But in this case, BDC can't equal 0 because our final answer has a C in the denominator. So that can't be 0. And B and D are denominators for our fractions. And so those can't be 0 either. Again, 0 in a fraction in the denominator is a no-no. Okay? And again, just like we were saying, if you can simplify the fraction, do it before you start dividing out any, before you multiply or divide them. Okay, so always try to get into its simplest terms first. The other thing, be aware of opposite factors, and what I mean by that, so if you look at the factors 2 minus 3x and 3x minus 2, they look like they're not the same, but they actually are. They're just off by a negative sign. So if I factor out a negative 1 from this 2 minus 3x, I actually get negative 1 times 3x minus 2. And so it's almost the same just for that negative sign. And so if we did have a fraction like that, so if we had 2 minus 3x over 3x minus 2, right? It doesn't look like I can cancel anything, but I can take out that negative 1. And then I get 3x minus 2 over 3x minus 2, and so I just get negative 1. So that's what I mean by look for opposite factors. Those actually do cancel now, and I'm left with just the negative 1. So look out for that as we do these, okay? So little take from The Simpsons. Imagine Bart Simpson writing this on the board at the beginning of the show, but always start by factoring. I can't stress that enough. Do not try to actually distribute 4k squared minus 2k minus 6 and 3k plus 2. Do not try to do that multiplication. It's really a factoring type of problem, okay? And so we're going to go through and we're going to factor everything you see, and then we're going to just hopefully be able to cancel some things out. So let's look here. 4k squared minus 2k minus 6. It looks like I can take a 2 out, and that's going to leave me with a 2k squared minus k minus 3, and over that, doesn't look like I can do anything there yet, so I'm just going to leave that 2k squared minus 9k plus 9. 3k plus 12, it looks like I can factor out a 3, So that becomes k plus 4. And it looks like I can factor out a 6 here, and that becomes k plus 1. Okay. So now I have to factor these trinomials. So let's see what we get here. We get 2k minus k minus 3. I believe it's going to factor, let's see here, minus 3 plus 1, I believe. It factors to that. And on the bottom, let's see, we'll get a 2k and a k. This sign is positive and this one's negative, so I know both of these have to be negatives. And I think 3 and 3. So let's just check. 2k times k gives me 2k squared. And then I get minus 3k minus 6k. That's negative 9k plus 9k. So those are our factors for that one. And then over here, it doesn't look like I can do anything. 3 over 6, I'm going to reduce that to 1 over 2. So we get k plus 4 over k plus 1. All right, so those are my factors there. I got a factor of 2 as well on the bottom still. All right, so 3 over 6, again, becomes 1/2. So now, let's change the color to cancel things, all right? So if I were to multiply this out, I would just multiply across the numerator, multiply across the denominator. But I'm going to see if I can cancel anything out. So it looks like a k plus 1 and a k plus 1 will divide to 1. So those are gone. We also have a 2k minus 3 and a 2k minus 3. So those we say bye to. I have a 2 and a 2, and we're going to say bye to those because they divide to 1. And so the only thing we're left with is our final answer of k plus 4 over k minus 3. There's our multiplying of these rational expressions. Again, if you tried to multiply this out, it's going to get ugly. But if you factor and then cancel, you get this nice expression here. Okay, so always start by factoring. And then once you factor it, look for things to cancel out that are in the numerator and denominator. I did forget to state the excluded values. So you're going to state the excluded values from this step right here. Not from the finished form. So my excluded values, it would be k can't equal 3/2. Again, all I'm doing is I'm setting each denominator's factors to 0. So this one will give me a k value of 3/2. This would be k minus 3 equals 0, so k can't equal 3. This 2 doesn't have a variable with it, so it doesn't matter. And then k plus 1 equals 0, so k can't equal -1. So those are our 3 excluded values for this problem. Okay, so that's an example of multiplying. Keys, do not multiply it out. Factor and cancel. Okay, can't stress that enough. All right, so moving to the next one, we're going to do a division example. Okay, and again, I'm going to always start by factoring. Okay, I'm always going to start by factoring. So, looking at this one, let's see here. Since we're dividing, I'm actually going to start by flipping my divisor. So I'm going to get 2x minus 1. Actually, retract that. We're going to start by factoring. All right, so 2x minus 1. I'm not going to flip it yet. 3x cubed minus 9x squared. I'm going to take out a 3x squared, it looks like. Yes. And that's going to give me an x minus 3. I'm going to divide that by. There's no common factor here, so I'm going to factor that. Let's see. So factoring that real quickly. So it looks like this one factors to 2x minus 1 and then a 2x plus 3. So I was just doing that on a piece of paper. And the bottom one, let's see, that will factor to, that one will factor to 2x plus 3 and an x minus 2x plus 3, and an x minus 2. Okay, so hopefully that is correct. All right, so what values can't we have? So we can't have any of these equal 0, so I'm going to do my excluded values right away. So x can't equal 0, right? So that comes from the 3x squared. X can't equal 3. X can't equal negative 3 halves. X can't equal 2, but if you remember from the previous slide, it also said that the C, so anything up here can't be excluded or included as well. So x can't equal 1 half, and x can't equal negative 3 halves, so we already have that one. Okay, so there's more excluded values for division problems. So now we can go through and we can actually cancel things out before I flip. So if I look here, it looks like I can cancel out a 2x plus 3 and a 2x plus 3. Okay, so we can say bye to them. So now we rewrite it by flipping our divisor. So we get 3x squared, x minus 3. I'm going to multiply by flipping now, so x minus 2. And on the bottom, we get a 2x minus 1. Again, now we can look and say, all right, well, I have a 2x minus 1 here and a 2x minus 1 here. So we say bye to them because they divide to 1. And it looks like our final answer is going to be x minus 2 over 3x squared times x minus 3. And that's how we divide our rational expressions. So a couple of key things here that are different than the multiplying. Excluded values are going to come from 3 items, and I'll highlight those with the magenta. So your excluded values will come from the factors with the underlined magenta, okay? Because if we have a fraction, right, if we do a over b divided by c over d, d and b can't be 0 because then those two fractions become something over 0. And then if c was also 0, right, then ab, this whole thing would be over 0, and that's not okay, right? So 3 things for a division problem that can't equal 0. The denominator of the dividend, and then the numerator and the denominator of the divisor. Okay, so there we have it.